Hello and welcome to my channel. I am Mensah Augustine. I welcome you to my series on application of differentiation, and this is rate of change. Now let's see the question we have on the board. Show that the rate of change of the volume of a sphere with respect to the radius equals the magnitude of the surface area. Find also the magnitude of change of the volume with respect to the surface area. Now, let's see how we do this one. Now, what is the volume of a sphere? The volume of a sphere is equal to 1/3 per r cube. And the derivative of the volume with respect to the radius is equal to 3 times 1/3 per r squared, which is equal to 4 pi r squared, as the derivative of the volume with respect to the radius. So here you see that the rate of change of the volume of a sphere with respect to the radius is equal to 4 pi r squared. And what is the formula for finding the surface area of a sphere? The formula for finding the surface area of a sphere is equal to 4 pi r squared. So you see that the magnitude of the surface area is equal to the rate of change of the volume with respect to the radius. So hence shown. Now, the next is we have to find also the magnitude of the change of the volume with respect to the surface area. So here we have change in volume with respect to radius, and this is the surface area. So let us find the change in surface area with respect to the radius. This is equal to 8 pi r. Wow. So now I have the v on the r and this s on the r. We can use the composite function, or we can divide this by that. So let's do that one, very simple. So here, if I take the v on the r divided by the s on the r, I'm doing this because they have the same denominators, and if this one turns upside down, this one will come and cancel it. So we have the v on the r times the r on the s is equal to the v on the s. So that this one will cancel this, and we get the chain rule, very simple here. So this is equal to the v on the r is 4 pi r squared. So you put 4 pi r squared. And we've seen that the s on the r has turned upside down. So we turn this one upside down to get 1 divided by 8 pi r. Wow. And this will give us pi will cancel pi, 4 will cancel 8, 2, and r will cancel one of the r. So we are going to have half of r. So the magnitude of change of the volume with respect to the radius, with respect to the surface area of a sphere, is half of the magnitude of the radius. It's half of the magnitude of the radius, as I've done here. I hope you've seen the cancellation clear. It is 4 pi r squared times, we turn this one upside down to get 1 divided by 8 pi r. So 4 will go into 8, 2. Pi will cancel pi, r will go into r squared, r. That is very good. Bye bye, and like, share, and then leave your comments. Don't forget also to subscribe.